one is the principle of interaction. This is also called Newton's third law. The statement of the principle of interaction, this is for memorizing, by the way. When body A exerts a force on body B, which is called Fa over B, then at the same instant, body B exerts on body A reaction force called Fb over A. What do I mean by this statement? Okay, first I'll show you this picture. Have you wondered why would you feel the force of the wall on your finger? When you press your finger on the wall, you will feel the same force, magnitude of the force opposing you. As you increase the force on the wall, you feel an increase of the force opposite feeling that you feel on your finger. Also, when two persons A and B are pushing each other, okay, they are standing on a roller skate or skateboard. When A pushes B or B pushes A, they both separate with the same magnitude. Why? Since when A pushes B, B pushes A in the same force. Okay, this is the principle of interaction. When person A exerts a force on person B called Fa over B, since A exerts the force on B. Thus, B will exert a force on A with the same magnitude. This is called the reaction force. Newton's third law is summarized as action equals to reaction. الفعل يساوي ردة الفعل. When you push the wall will push you backwards. So this is the principle of interaction. Let's read the statement again. When the body A exerts a force on body B called Fa over B, A on B. Then at the same instant, B exerts on a reaction force called Fb over A, B on A. Okay, I think it's clearer now. The action and reaction have the same line of action. Since when you push the wall horizontally, it will push you horizontally. The same magnitude. As you push the wall more, you will feel an opposing force more on you. The same magnitude and opposite directions. You push the wall inwards, it pushes you outwards. Okay. So Fa over B is equal to minus Fb over A. Notice here the vector over the force, and here the magnitude relation. We don't have vectors. And the minus means opposite direction in the vector form. Okay, now simple examples. When you have the two magnets attracting, since N is facing S, the two forces F2 over 1, F1 over 2 have the same magnitude. Okay, same magnitude. Notice here, this magnet is 1. The force is F2 over 1. Since this force is exerted by 2 on 1, it's pulling it towards it. Okay, so let's assume that I'm magnet 1. I'm pulling بسحب اللي عندي magnet 2 towards me. So this force is exerted by me, magnet 1 on 2. So it's called F1 over 2. While this force is F2 over 1 since 2 is pulling magnet 1 towards it. So this is the force exerted by 2 on 1. Similarly, between the table and the box. The table is holding the box, so it's exerting a force, upward force, called F table over box. At the same instant, the box is pushing the table downwards. This force is called F box on table. By the way, this is not the weight. The weight is drawn from the center. This is the force exerted by the box on the table. I think it's irrational to you in this case, but actually, the questions are in two ways. You are either asked to mention the forces acting on the box, so they are weight and normal, or to mention the forces of interaction between the box and the table. In this case, we talk about F table on box, F box on table. So it's either this or that. Okay. Similarly, for this forces, tension and weight, and the when you ask the forces between the on the object.